Number 41. A voltaic cell is constructed with the overall reaction, which change will increase the voltage of the cell. I'm going to answer this in terms of Le Chatelier's principle. Alright, starting with A, I'm going to increase the concentration of tin2 plus. Then it's going to favor the forward reaction, and that's going to increase the driving force of our electron flow. And that caused the voltage to increase. Therefore, the answer is simply A. Now you can contrast the other choices again by using the Le Chatelier's principle. When we increase the tin4 plus, it's gonna favor the reverse reaction, and that's gonna deter our electron flow, the driving force of electrons, and therefore that's gonna cause the decrease in our voltage. So B is out. In the same reasoning, C is also out, because by decreasing the concentration of silver ion, it's gonna favor the reverse reaction. Now, the reducing the size of the electrode is going to be independent of our voltage, so answer is A. Number 42. Use the standard reduction potentials to determine what is observed at the cathode during the electrolysis of a 1.0 molar solution of potassium bromide that contains phenol. What observation is made? Okay, so let's write down the major species. In our solution, potassium ion, bromide ion, and water is to be observed. Looking at these four reactions, we have to determine what happens at our cathode. Okay. I have potassium ion that can undergo reduction. Okay. And water also can undergo reduction. And which one do you have to use? Well, the first reaction is for the oxidation. The water undergoes oxidation by flipping the sign of cell potential. But third equation undergoes reduction for our water. And now we have to determine which one is reduced. We compared the cell potential for each half reaction, and it really favors the higher magnitude of cell potential. Definitely number 3 is higher. So the reaction favors reducing water than our potassium ion. Therefore, at cathode, these reactions are happening at cathode. We expect the hydrogen gas bubbles to arise, and we already added phenol. So adding phenol in the hydroxide caused the solution color to appear as pink. So we have bubble and pink color solution. So that exactly matches our B. This is what happens in our cathode. Answer is B. Number 43. To whom is the discovery of the nuclear atom attributed? If you know who it is, it's D. Rutherford made a gold foil experiment. So he had this alpha particle emission, and he had a gold foil that had that the emission went through. Here's a gold foil, and then we have metal. I believe it's metal. We have lead box with alpha particle in here that shoots our gold foil. Okay, this is gold, and then we observe the deflection. Okay, most of the emission went through the gold foil because atom is mostly empty space, so it would go like, mostly this. However, some of them actually deflected due to the presence of atom, the nucleus. I'm sorry, the nucleus. Okay, some of them even shoot back where it came from when it hits directly at the nucleus atom. And therefore, he was able to conclude that in the atom there's a very heavy, dense nucleus present. And he also found the atom is mostly empty space. So answer is D. Louis de Broglie. Okay, let's start with A. Niels Bohr made a Bohr model in which the hydrogen atom the electron in the hydrogen atom can have a circular orbit, and although it doesn't work beyond that model, beyond hydrogen, and he doesn't discuss about the nuclear atom. A is out. Louis de Broglie showed that the electron can behave as a wave, and that's not it. C. Robert Millikan found the charge of an electron, and thus he was able to conclude the mass of an electron. So C is also out. Okay. Number 44. Each of the following atomic orbitals is possible except, okay, you never see 3f. Why? Let me show you by, okay, when I have n equals 1, n equals 2, n equals 3, and n equals 4. For the principal number of 1, I can only have s orbitals. But when I go to the second row, the energy level increase and also the size of the orbital increase. Now I can have both s and p orbitals. Now when I move to the next level, I can have s, p, d orbitals. And then when I go to the fourth, that's when I can have f orbitals. Because you see in the row 3 there's no f, and in our choice we have 3f, so that's not possible. So this is number 44, that's number 43. Okay, number 45, the ion manganese 2 plus cation contains which combination of protons, neutrons, and electrons? Okay, this is a very easy problem. Just be careful that number of neutrons and number of protons make up the atomic mass. Okay, according to the periodic table, the manganese proton number or manganese atomic number is 25. Okay, it's in the transition metal on the first row. Therefore, number of protons don't change. So anytime you change the number of protons, they become different atom, a different element. So C and D are out. Okay, they don't even represent the manganese. Now let's also determine the electrons. Well, actually, it doesn't really help us because they have a right number of electrons. When you have 25 protons, but you lose 2 electrons, then you subtract 2, and therefore you get 23. Now, you can determine the answer by the number of neutrons. The mass number is 55. And we already have 25 protons, and we have to find the number of neutrons. If you subtract both sides by 25, n equals 30, and therefore answer is A.